Second method of finding the determinant for matrix 3 by 3 method is by using the minor and the cofactor that we have learned in the previous slide. Okay, so this is where we will apply the minor and the cofactor that we learned. Alright, so the way is, okay, you can expand along the ith row, okay, or expand along the jth column. So you can choose either one, and you can expand any row you choose or any column you choose. Okay, alright. So the way is, you need the element of the row or element of the column that you choose. You multiply with the cofactor of the matrix A. Okay, that will give you the determinant. Alright, so I will show you on how to find determinant for 3 by 3 matrix by using these two methods in the next slide. Okay, first let us apply the first method. Okay, so please take note that both methods should give you the same answer. Okay, so it doesn't matter which method you choose, you should get similar determinant. Okay, same determinant. Alright, so in the examination, if you were asked to use that a particular method, you must use the method mentioned. Okay, so you don't have have the freedom to choose which method unless it didn't mention anywhere in the question for you to apply a specific method. Then you are free to choose which method you are comfortable with to solve for determinant. Alright, so let us apply the first method. Okay, so let's say if you have matrix A, okay, this is 3 by 3 method. 3 by 3 matrix. So by applying the first method, which is adding up 2 more columns at the back of your matrix, so that it will become 3 by 5 matrix. Okay, so write it like this. Okay, finding the determinant. Since this is determinant, so we will put our numbers in between the two straight line. Alright, so copy the matrix back to this. Okay, 6 minus 2, 0, 3, 8 minus 5, and please add 2 additional column. Okay, by writing the first 2 row. Okay, so the first one is minus 4, 7, 1. And then the second is 6 minus 2, 0. Okay, and then please close the bracket back, the straight line. Okay, now we will do the multiplication. Okay, so the first one is, I use the highlighter then. Okay, so the first one is this multiplication. Okay, so oops, why is this red now blue? Okay, so minus 4 multiply with minus 2 multiply with minus 5. Okay, plus with the next one. Okay, next diagonal, which is this. Okay, so 6 times 8 times 1 plus with the next diagonal, which is this multiplication. Okay, 3 multiply with 7 multiply with 0. Okay, we're done we close the bracket. Okay, then we will subtract with, okay, open the new bracket. Okay, the product of this diagonal. Okay, so what is the number? 6 multiplied with 7 multiplied with minus 5. Okay, so we plus with the diagonal of that. Okay, so minus 4 multiply with 8 multiply with 0 plus with the last diagonal, which is 3 minus 2 and 1. Okay, so 3 times minus 2 times 1, close the bracket. Okay, so you solve one by one all the operation inside the bracket first. Okay, so 8 times this minus 40. Okay, plus with this one, 6 times 8 is 48, plus with 0. Okay, close the bracket. Minus with, now solve for this bracket. 6 multiply 7 multiply with minus 5, that is minus 210. Okay, and then plus with 0 minus with 6. Okay, so that is equivalent to 8 minus plus 216. That will give you 224. Okay, so the answer is 224, determinant for matrix A. Right? Easy? Understand? Could you do that? Hopefully yes. Alright? Okay, now let us apply the second method, which is by using cofactors. Okay, by expanding along the ith rows or the jth column. Okay. First step, we need to determine whether we want to expand by using the row or the column. And if we choose the row, which row do we want to expand? And if we choose the column, which column we would like to use? Okay, regardless of the method and whether by using the first or the second, and regardless of expanding the column or the rows, okay, we should expect that we will get the same answer, which is the determinant for matrix A is 2, 2, 4. Alright, okay, so here we have two ways, okay, to expand by using the cofactor. Right, so the first one is by expanding the ith row. So since we have 3 by 3 matrix, means that we have 3 rows, 3 columns. Right? Okay, so if we choose to expand the ith row, we can choose either first row, second row, or third row. Okay, so it doesn't matter which row. You should get 2 to 4 for the determinant. Same goes if you use to expand the jth column, which here you have 3 columns. The first column, the second column, and the third column. Alright, so let us choose the first row. So here I choose to expand along the first row. Okay, and please take note that this example is the example from the previous example for finding cofactor. Remember? Okay, and we got the cofactor of matrix A equivalent to this. Alright, to this. Okay, if you couldn't remember on how to find the cofactor, please go back to slide of finding cofactor. Okay, then you will get the answer from there. Alright. Okay. Okay, so since I choose the first row, so what we need to do first is we need to mark where is our first row in our matrix A and in our cofactor. Okay, so I will choose the highlighter. Alright, so we start from matrix A first. Where is our first row? Okay, so this is our first row. Okay, next, in our cofactor A, where is our first row? This is our first row. Okay, once we do that, okay, we can start multiplying our matrix to find the determinant. Okay, so okay, now by expanding along the first row, our determinant A is, okay, so the first element, okay, first row, first column of matrix A will multiply with the first element of the first row, first column. Okay, so now negative 4 multiply with 10 plus with the first row, second column of matrix A, which is 6, multiply with the second element from the first row, second column, which is 43, plus with the third element from the first row, third column, with the third element in the first row, third column of the cofactor. So 3 multiply with 2. Okay, when you solve this operation, you should get 2, 2, 4. Okay, so remember, okay, this calculation looks easier because we have went through the complex calculation in finding the cofactor. So you already have the cofactor. Okay, so if you first get the matrix A, okay, you need to do from the scratch. Okay, so you need to find the minor, you need to find the cofactor, and lastly, you need to choose whether you want to expand the row or you want to expand the column. Okay, right. So since in this example, we just proceed from the previous example where we had already found the cofactor. So this is how it looks like. Okay, so it will be simple. Alright, so expanding along or the row or expanding along the column will simplify the way you find the determinant if you compare to the first method. Okay, so in this method, second method, you just need to do 3 multiplication, 3 addition to your matrix. Okay, now let us try to check whether expanding along the column will get the same determinant or not. Okay, so let us choose expanding along the second column. Okay, so we will repeat the same method. We mark down where is our second column in the matrix A and in the cofactor A. Okay, so our second column for matrix A is this. This is our second column, right? And the second column for cofactor A is this. Okay, so we'll do the same step, right? So the determinant of matrix A, when we choose to expand along the second column, is, okay, the first element of the second column, which is 6, from matrix A, multiply with the first element from the first column of cofactor A. So 6 times 43 plus, it always plus, okay, it always add. Okay, the second element from the second column, which is minus 2, multiply with the second column, okay, from matrix cofactor A, which is 17, plus the third one from A, which is 0, multiply with 53 from cofactor A. And if you substitute these values into your calculator, you should get 2, 2, 4. Okay, so it doesn't matter whether it is row or column you expand, okay, whether the first, the second, or the third, okay, you should get similar answer if you find the correct cofactor for your matrix A. In the examination, please alert with the question needs. Okay, you might be asked to expand along the specific column or specific row. Okay, if you were told to do so, please follow. Okay, unless it didn't mention any specific column or row to expand, then you are free to choose which row or which column to expand. Okay, so now we know how to find the determinant for the higher order of matrix. Alright, so first we have this first method, which is the general method. You just add another 2 extra columns at the end of your matrix. Okay, the second method is by using the cofactor method, okay, where you need to expand along either row or column. Okay, so next we proceed to the property of the determinant. Why do we need to know the property of the determinants? Okay, it is just simply to help us to save time, okay, and avoid a complex calculation involving determinant of the matrix. Okay, that's it. So if you let's say you have matrix A, which is the square matrix. Okay, why it is square matrix? Because you have n by n matrix and you have k as a scalar. Okay, and you have matrix B, which is obtained by multiplying your k, okay, to any single row or column of matrix A. Then if you are asked to find the determinant for matrix B, it is equivalent to your to multiply the scalar to the determinant of matrix A. Alright, so if you know the determinant of matrix A and you have the new matrix B, you do not need to calculate again. We do not need to repeat the process of finding the determinant for matrix B. Okay, what you need to do is you just multiply the scalar to your determinant of matrix A, and you get your determinant of matrix B. Okay, to see it clearer, alright, let us take the previous example where you have matrix A equal to minus 4, 7, 1, 6 minus 2, 0, 3, 8 minus 5. Okay, so this is the previous matrix, okay, from the previous slide, where we calculate that determinant of this matrix is 2, 2, 4. Okay, so let us set that k equal to 2. And I claim that matrix B is scalar k, which is 2, multiplied with the third row of matrix A, which means 2 multiplied to the third row. Okay, multiply with this. That is our new matrix, which is matrix B. Okay, so we get that matrix B is, the rest of the row remain the same. So 4, 6, 3, 7 minus 2, 8. Okay, so we multiply the scalar to the third row. Now it changed to, the third row changed to 2, 0 minus 10. Okay, so this is what it means by this sentence. Okay, the matrix B is obtained by multiplying a single row or column of matrix A by K. So since I choose row, so I choose the first row. It doesn't matter, you can choose first, second, third row. Same goes to column. Okay, so anyone. Alright. Okay, so this is matrix B. Right, so if I ask you to find the determinant for matrix B, okay, by knowing the property of the determinant, okay, you do not need to repeat the same process of finding determinant A, okay, because now you know already your determinant A is 2 to 4. And you multiply 2 as a scalar. So by applying the property of determinant, determinant B is just simply 2 times 2 to 4. So it is 4, 4, 8. See, you save time. You don't have to go through a complex calculation. Okay? Okay. That is what it means by the first property. Okay. Second property say, if you have matrix A multiplied by K, that is every element in the matrix is multiplied by K, then determinant of K multiplied with matrix A is equivalent to K to the power of n, means the whole scalar to the power of n, times the determinant of matrix A. Okay, so the second property says you multiply scalar K to every element. Okay, so let's say if you have K equal to 2, okay, it will multiply to every element in A here. So you have new A, okay, Ka, which is 2 multiplied with matrix A, you get minus 8, 14, 2, 12, minus 4, 0, 6, 8, 16, minus 10. Okay? So if you were asked to find the determinant of this new matrix, okay, you just apply the determinant properties. You don't have to calculate, go through the hard process. Okay, just take k, which is 2 to the power of n, okay, times the determinant of matrix A, which is 2, 2, 4. Okay, what is our n? N is our order, the order of our matrix. So since this is 3 by 3, okay, so our n, sorry, 3 by 3, so our n is 3. So here, 2 to the power of 3 times with 2, 2, 4. So you will get the answer for the determinant of matrix 2A. Okay, so multiply this, you will get the answer. Alright. Property number 3. Okay, if you have B which is obtained from A by interchanging the two rows of two columns, then determinant of that new matrix B is equal to the negative determinant of matrix A. Okay, so you know that A is minus 4, 7, 1, 6 minus 2, 0, 3, 8 minus 5. Now, I claim that new matrix, which is matrix B, is the interchanging between the second row and the third row. So, I change this row, these two rows. I change the position. Okay, so matrix B is, the first row will remain. Now, second row will become the third row. So, 7 minus 2, 8. And the third row will go up to the second row. So, 1, 0, minus 5. Okay, if you know that your determinant A, which is 2, 2, 4, then if you are asked to find the determinant of matrix B, it is just equivalent to negative of determinant A, which is negative 2, 2, 4. That's it. It will be the same if B is the changing between the column. Any column, doesn't matter. Okay, if you change this first column with the second column, for example, you still get negative 2 to 4. Okay, so next property is adding or subtraction or multiple of one row or column to the other row or column, leave the determinant unchanged. So if you subtract or add one row with another row, or one column with another column, okay, the determinant will be unchanged. Okay, so for this property, I will just take a simple matrix, which is matrix 2 by 2. Okay, so that it is easier for us to calculate determinant compared to calculating the determinant for matrix A, for matrix 3 by 3 or higher order matrix. Alright, so let's say if you have A, which is 2, 5, 1, 4. Where is the, okay, 1, 4. Okay, let us find the determinant of this matrix A. It is 2 times 4, which is 8, minus with 1 times 5, which is 5. So 8 minus 5 is 3. Okay, so 3. 8 minus with 5 here. So 3. Okay. Now, I said that I have a new matrix A, where this new matrix A is equivalent to taking the first column, okay, subtract with the second column. Okay, so by doing that, you will get new entry for your first column. Okay, so what is the new entry for the first column? It is first column minus with the second column. So 2 minus with 1 is 1. 5 minus with 4 is 1. and the second column will remain because we do not change anything to it. We just change this first column by subtracting the first column with the second column. Okay, so the only column that change is the column 1. Okay, so column 2 remain unchanged. Alright, so now let us find the new determinant for matrix A. Okay, so 1 times 4, which is a 4, minus with 1 times 1, which is 1. So we'll get determinant equal to 3. So they are similar, right? Okay, that is what it means by the fourth property. Okay, if you apply for row, you get the same answer as well. Alright, so this property, this example also apply to the higher order of matrices. Okay, alright. So the fifth. Okay, so the fifth say if A and B are two square matrices such that A, B exists, then determinant of matrix AB is equivalent to you find the determinant for each of it and then you multiply later. Alright, so if you have matrix A, matrix B, and they are square matrices, mean they are n by n matrix, okay, and there is exists multiplication of matrix A and matrix B, okay, means they have the same order, so they can be multiplied. If for multiplication, if they do not have similar order, so it is quite difficult for you. I mean, it must follow the rule for multiplication, where the column of matrix A must be equal to the row of matrix B, only then AB will exist. Okay? So when AB exists, okay, you find the determinant of matrix AB, okay, is equal to you find the determinant of matrix A separate, okay, and then you find the determinant of matrix B, okay, and you multiply them later. It is equal. It's either for you to multiply the matrix first and then proceed with finding the determinant, or you can find the determinant respectively for A and B and then multiply the determinant. They are equal. Okay, right. So the last property is if two rows or two columns of a matrix are equal, the determinant of the matrix is 0. Okay, so if you see two columns or two rows of the matrix are equal, so you don't need to proceed to finding the determinant because it automatically become 0. Okay, for example, if you have matrix A is minus 4, 6, 3, minus 4, 6, 3, and then 1, 0, minus 5, you don't need to waste your time to calculate the determinant of matrix A because by applying the property of the determinant, this is automatically a 0. Okay, same goes if you have matrix A where they have equal column minus 4, 7, 1, minus 4, 7, 1. This is 5, 2, 0. Okay, this is also 0 for determinant. Okay.